Alright, we're in our last section of Chapter 1. We're in Section 110, where we're going to talk about mathematical modeling and variation. So we're actually going to jump right into our first example, where we are going to be using a mathematical model to represent the following table. So one of our variables we're looking at is year, and the other one is population. So what we're going to really do from this is we're going to write an equation to model the table. So we're starting year 2008. In the year 2008, now this table represents populations in millions in the United States. So the year 2008, there were 304.1 million people in the U.S. In 2009, there were 306.8 million. 2010, we had 309.3 million. 2011, there were 311.7. 2012, 314.1. 2013, we had 316.5 million. And I still have two more spaces, so I'm going to have to go down into another row. 2014, we had 318.9 million, and in 2015, 321.2. Now, to actually write an equation to model this, we're going to use some type of graphing utility. I'm going to show you here in the video how to use Desmos to do that, and then I will also give you a step-by-step process you would do to do this on a graphing calculator. So let's pull up Desmos. Alright, so here we are in Desmos. When we want to make a table, we're going to hit this little plus sign and pick table. This X1, we're going to use that to represent our years. And instead of writing 2008, we're going to just use the number 8 to represent that. So 2009 will be 9. 2010, we're going to go all the way up until we hit 15. And then in our Y1 column, we're going to use our other data points, our population. Those we have to type in. 304.1, 306.8, and give me a second and I'll get these all typed in. Alright, I'm on the last one. Alright, so I finished typing them into my table, but I don't see any of them here on my graph. So what I'm going to do is I'm going to hit this little tool above the plus minus, the zoom in, zoom out, and I'm going to adjust my X and my Y axis. On my X, I see that I don't go any lower than 8, so let's just switch that negative 10 to, let's say, a 7, just a little bit less than 8. And let's switch that 10, since we don't go past or since we go up to 15, let's just switch 10 to be 17. We go a little bit past 15. Now, still don't see anything, so we have to adjust our y-axis. Our y-axis is a little too spread out. So instead of -7, in fact it's not spread out enough, instead of -7.8, let's switch it to 280, since we don't go any lower than 304.1. And we could even go 300. Instead of 7.8 being our max, since we go to 321, let's just go to 330. You can pick whatever numbers you want. Now we can click on the tool again to get rid of that, and look at, we have our points. So now to write a model, write an equation that's going to work for this, we have to hit the plus sign again and pick the expression option. So what we're going to do is we're going to type in y1, and instead of an equals, we're going to put that little squiggly line, x1 plus b. And what we have here now is they gave us an m and a b value. So we can take those numbers, 2.43, and use it for m, and 284 point rounding, we'd call it 87, and we can make an expression. So let's go out of Desmos and onto our paper again. So our equation is going to be y equals, we've got y equals 2.43 x plus 284.87. Let me write that again. So what this means is we can use this model to make some future predictions. Well, let's give that a try too. Let's say we want to predict what the population in the U.S. would be in the year 2020. All we would need to do is take our equation here and put 20 in for x. So we're going to have 2.43 times 20 plus 284.87. And I would say go ahead, use a calculator to figure out what this number is. And from typing this into my calculator, I would get that in the year 2020, the population of the U.S. would be 333.47 million people. Which that part wasn't part of the question we had, but I thought, why not give it a little fun? So on the next slide, what I'm going to do is I'm going to give you the step-by-step instructions on how to do this on a graphing calculator. You'll need to pause the video so you can copy it down. So here are the steps that I would take on a graphing calculator. It looks like a lot, but once you get used to how to type it in, it goes real fast, and you'll be allowed to use a graphing calculator on something like the ACT or any kind of standardized test. So that last example was a linear model. The points made a line. We're going to also be talking about direct variations, which are a type of linear model. So most linear equations are written in the form y equals mx plus b. typically b is not going to equal 0. So that is our typical linear model. With a direct variation model, the equation is going to be in the form y equals kx. And typically, we'll know to use this type of model, direct variation, if we see something where it says y varies directly as x, or they might even say, or it is directly proportional to x. Now, direct variations do have some characteristics, so we're going to list those here. So the statements below are all equivalent. Our first statement, y varies directly to as x. Our second, y is directly proportional to x. And our third, y equals kx for some non-zero constant value k. And in this case, k is called the constant of variation, or also sometimes called the constant of proportionality. So let's look at our next example. Example 2, which is a word problem. It's going to state, in Pennsylvania, the state income tax is directly proportional to gross income. You work in Pennsylvania. And your state income tax deduction is $46.05 for a gross monthly income of $1,500. We are going to find a mathematical model that gives the Pennsylvania state income tax in terms of gross income. So first, I like to write a verbal model so I know what's going on. What I know is the state income tax is equal to the constant of variation that's always going to be in there, times someone's gross income. So whatever someone has to pay for their state income tax, it's some value times their gross income. Now, what I also would like to do is, I don't really like using, and most mathematicians don't like to use long words in here. So we're going to change some of these words into variables. So why don't we let y represent our state income tax, and we'll let x represent the gross income, and this k value, it actually does represent something. It is the tax rate, the income tax rate. So y equals kx. We have a direct variation problem. There are some things we know. This is a basic equation. We need to figure out k. Let's take the income tax and the gross income that we know and put them in here. So we know from the problem, or from what we've been told, the income tax deduction of this person is 46.05. So we're going to put that in for y. 46.05 equals. We don't know, and we won't know k quite yet, but we do know this person's gross income is $1,500. Now we want to solve this for k. So that means we're going to divide by 1,500. When we do that, we're going to find out that k is equal to 0.0307. And you can confirm that. Type 46.05 divided by 1,500 into a calculator. You'll get that back. What we can do now is, in the equation we had, we can replace k with this number we just found. So our model is going to be y equals 0.0307x. With this, it doesn't matter what someone's income is. We can figure out what their income tax deduction will be. So sometimes we can also have direct variations. As an nth power. Now that might seem confusing. So let's just write on, and when we get to our next example, we'll talk about what this nth power thing means. So the statements below are all equivalent. So 1, y varies directly as the nth power of x. It might say y varies directly as the square of x. We could have y is directly proportional to the nth power of x. Or we could have y equals kx to the power of n for some non-zero constant k. So now let's actually look at an example. And we don't have time to look at an example for this, so we'll see that in our next video.